So, okay, got it.
Right.
So, Assalamu alaikum, everyone. I am Swed Redwan Mohammad Hassan, your host for the evening. Indeed, very wonderful. Many participants are still joining. Well, I would like to welcome you all to this prestigious distinguished lecture program on Grid Modernization, Technological Innovations Beyond Smart Grid, organized by IEEE North-South University Student Branch in collaboration with IEEE North-South University Power and Energy Society Student Branch Chapter, IEEE Multimedia University Student Branch, IEEE Power and Energy Society Multimedia University Student Branch Chapter, and supported by IEEE Power and Energy Society Chapter Student Activities Committee. As we all know, during this pandemic situation of coronavirus, we have been facing a world crisis since the beginning of 2020. Despite going through the second wave of this pandemic around our country, all of you managed to join the event, and we really appreciate that. I would like to request everyone to turn off their microphone to avoid any type of noise. So about the event, about the PACE Distinguished Lecture Program. It's a worldwide program that provides lectures in person and through webinar format. The lectures are well-known power engineering engineers who have been working in their specialized areas for a long time. Apart from the technical expertise, they have been actively volunteering for PACE through various chapters, relevant roles locally, regionally, or at the governing board of the society. Okay, for this special event, we have the honor to have John McDonald, who is an IEEE Power and Energy Society distinguished lecturer since 1999. The topic of his evening's lecture will be Grid Modernization, Technological Innovations Beyond Smart Grid. This lecture will introduce attendees to a vision for grid modernization with an emphasis on the technological development beyond smart grid, discussions of major industry societal trends, smart grids, holistic solution integration of microgrids and distributed generation and advanced distribution management systems, software applications are among the technological advancement. Now, if our honorable speakers allow us, we would like to take a few snaps now, sometimes due to some technical difficulties of the number of participants falls down. So I would like to request, sir, with your permission, may we take a few snaps, sir, Dr. Professor Shohidul Islam Khan, sir, and John McDonald?
Sure.
Okay, thank you. So I'd like to request Shofikul Islam Saqib, our core volunteer, to take the screenshots. And meanwhile, I would like to request everyone to turn on their camera.
Please everyone turn on your camera. Okay, 3, 2, 1. Another one. 3, 2, 1. Thank you, everyone.
Shofik, I think you can wait for a minute. Maybe some people are still turning on their camera.
Yeah.
Yeah.
Okay,
Let's
sure,
just give a few seconds. Okay.
Okay.
Yes, Shofikul, so you can take the picture now, I guess.
Okay. 3, 2, 1. Thank you, everyone.
Thank you so much, Shofikul Islam Saqib. So, okay, now is the time to introduce the special guest of today's event. Shohidul Islam Khan, sir, Professor, Chair, IEEE Power and Energy Society, Bangladesh chapter. He served as the founding chair and the chair of IEEE Bangladesh section in 1993 to 1995, 2000 to 2002, and 2005 to 2006. Also served as the chairperson of Power and Energy Society, IEEE Bangladesh section from 2012 to 2013 and 2016 to 2017. Since 2013, he has been an editorial board member of the IEEE flagship open access journal, IEEE Access, on the national renewable energy policies. Dr. Khan is a consultant in many projects for the government of Bangladesh and appears regularly in the national media, TV or newspapers, or we can say radio even. He supervised more than 12 master's theses, numerous bachelor theses, and carried out many research activities funded through the government of Bangladesh and GIZ. So now I'd like to request Dr. Shoidul Islam Khansar to take over and give an opening remarks for all of us. Thank you so much.
Thank you, Ridwan, for the good introduction. Thanks a lot. My dear student members, best distinguished lecturer, Mr. John McDonald, welcome to today's seminar. Of course, you are the speaker. I must thank Multimedia University, Malaysia, and North-South University, Bangladesh student branches for jointly organizing this seminar on a very innovative topic. I hope and wish the future power engineers will be benefited from this webinar. My gratitude and sincere thanks to Mr. McDonald. All the best. Please enjoy the webinar and greetings from IEEE PES Bangladesh chapter. Thank you.
Thank you so much, sir. It was a wonderful conversation. And yeah, so now the time has come to introduce our today's lecturer, Dr. John D. McDonald, PE, the keynote speaker of the Grid Modernization, Technological Innovation Beyond Smart Grid. He is Smart Grid Business Development Leader for Grid Solution Business. John has 47 years of experience in the electric utility transmission and distribution industry. John is the past president of the IEEE Power and Energy Society and the vice president for technical activities for the U.S. National Committee USNC of CIGRE, the past chair of IEEE Power and Energy Society Substations Committee and the IEEE Division 7 past director. John was the board of the governors of the IEEE Standards Association and is an IEEE Foundation director. John received 2009 Outstanding Electrical and Computer Engineer Award from the Purdue University. John has published 150 papers and articles, has co-authored 5 books, and has 1 US patent. John D. McDonald is the life fellow of IEEE, who has been member since 1971, and he has been the member for 50 years and awarded the IEEE Millennium Medal, the IEEE Power and Energy Society Excellence in Power Distribution Engineering Award, the IEEE PES Substations Committee Distinguished Service Award, the IEEE Power and Energy Society Meritorious Service Award, the 2016 CIGRE Distinguished Member Award, the 2016 CIGRE UNSC Attitude Associate Award, and the 2021 CIGRE Honorary Member Award. I would like to welcome John McDonald, sir, and give his lecture on Grid Modernization, Technological Innovations Beyond Smart Grid.
Thank you. Thanks, Saeed. Thanks, Maisha. Thank you to Professor Khan. Nice to meet you. Nice to see you again. This is I love working with this group. The more opportunities I get to be with you, it's fun. Really get energized by your your drive, your motivation to do well. And what I want to do today, as you guys said, is talk about not what we've been doing or not what we're doing today with Smart Grid, but what we're doing for the future. And this could be things like, this could impact maybe courses you decide to take, or research topics you decide to do, because some of these are pretty exciting and things that we need for the future. So I'm going to share my screen, okay, and bring up the slides. And let's see, put it in slideshow mode. There. Can you see the slide?
Yes, sir.
Yes, sir.
All right. So one of the things I want to point out, and Maisha, you said this in the chat area, but we'll have plenty of time for questions at the end, but also I'm going to refer to articles I've written, books I've co-authored. If you want any copies of these articles, let me know. And I'll show my email address here in a minute, or you can chat with me on LinkedIn and let me know. I'd be happy to send you information on the books or copies of the articles. Okay. Now, those of you that know me pretty well know that work-life balance is very important. I'll just briefly mention this before we get into the technical talk. And all of you should really take good care of yourself health-wise, eat healthy, get regular exercise, and get enough sleep at night. I know that's tough for some of you, and just take good care of yourself, okay? Being healthy and feeling healthy, exercising regularly actually helps your schoolwork, and it helps get everything done, I think, more effectively and more efficiently and better quality, okay? So this is something that's been very important to me. I just had a very, very tough workout just a few hours ago this morning. I start every morning, 5 mornings a week, with a tough workout with my trainer, who's in the picture in the lower right. And the upper picture in the upper right is, we just finished a 5K race, my son and I, when he, the day after he got his MBA at Duke University. He's a Georgia Tech electrical engineer and then a Duke University MBA. So these are the topics I want to talk about. And remember, it's grid modernization, technological innovations, advancements beyond smart grid, beyond what we've been doing. These are the topics I'm going to touch on. Again, if you have any questions, let me know. And if you want copies of anything that I refer to, let me know. Let's see if, yeah. So the first thing is, and I want to emphasize this, is I start with this because you really have to know what's happening in the world around you. And in the, many of you have seen my webinar on key insights to career management. And one of the things I emphasize there is you need to have a balance between internal and external focus. Internal focus, if you're a student, is you just go to your classes and do your coursework, and that's all that you do. A balance between internal and external focus means you do well with your schoolwork, but you also get involved in groups like IEEE, okay? Take leadership positions, and you learn more about technology through IEEE. You expand your network of industry contacts, and you also volunteer, hopefully, for leadership positions. I've always volunteered for leadership positions in the 50 years I've been in IEEE, because I benefit. I get more benefits by being more involved, okay? So in the real world, you have to know what's happening in the world around you. And that's why these trends are important. Otherwise, decisions you're making for your company, let's say, may not be the best decisions. You think they are, but you may be costing your company a lot of money because you don't know what's happening in the world around you. So some of these trends are, we've transitioned from devices and systems to holistic solutions. Now, in the early 1990s, when I was leading the revision of the IEEE standard on SCADA, supervisory control and data acquisition, and last Saturday I gave a webinar for a group in India just on SCADA, supervisory control and data acquisition. But we introduced a term to IEEE called Intelligent Electronic Device, IED. And these are the new microprocessor-based devices that have internal processing capability and two-way communications. So we're transitioning from just the device or just the system to a holistic solution. And I'm going to show you in a minute here 6 holistic solutions. Now, these 2 words are very important. Holistic means company-wide or enterprise-wide. We don't want to just do something for one group in the organization, like protection or planning, but we want to break down the silos among the groups and have everybody work together holistically. And then a solution is a set of technology components, could be devices, could be systems, could be power system equipment. So components that are integrated together to successfully interoperate to meet the business needs of the customer. And again, I'll show you 6 holistic solutions in a minute, okay? But this is important. And when I teach, like in the next couple of weeks, I'll be teaching 2 graduate courses at the University of Tennessee, Chattanooga, one on smart distribution systems and one on modern substation concepts. The substation concepts course uses my book, Electric Power Substations Engineering, and the smart distribution course uses another book that I co-authored called On Smart Grid, over 800 pages just on Smart Grid. So we teach, though, as a student or young professional, always be thinking of the big picture. Don't just be happy with the device in the substation, but that device has two-way communications. Think of an integrated solution. And the reason is the holistic solution has many more benefits to the customer than just the device itself, okay? So success now is like a 3-legged stool, a stool with 3 legs. What happens if you sit down on a stool and one of the legs is weak or is missing? It's unstable, you'll fall over. So what I mean there is success, these 3 legs are all equally important: technology, standards, and policy. So technology today must be standards-based for successful integration and interoperability. And I'll finish this talk here with talking about industry standards. You know, I got involved in writing IEEE standards in substations over 35 years ago. I was in charge of this book, Electric Power Substations Engineering, 22 chapters on substations, the most widely used practical reference book today on substations. It's in this 3rd edition. And I chaired that committee in 2001 and 2002, 500 of the world's experts on substations writing all the standards on substations. So, you know, I knew early in my career that getting involved in standards was important for me because it helped me learn the technology much better and expanded my network of industry contacts with many, many key experts around the world that I depend on, you know, to help me keep up with all the new technology in substations. Now, policy is very important because policy is the strongest driver to encourage the customer to buy my technology. And you know, one example of that is in the state that I live in the United States, in the state of Georgia, we had a policy in the state, $7,500 to encourage people to buy or lease an electric vehicle. And when we had that policy, hundreds of people were leasing or buying Nissan Leafs at the time. You couldn't find a Nissan Leaf at a dealership because of this policy encouraged people to you know, to buy or lease. When that policy expired a year and a half ago, literally people stopped, the rush, the enthusiasm to get a Nissan Leaf or any EV went away. Policy was a very strong driver there. And it's true that when you have a strong policy, you see tremendous investment. When a policy goes away, investment goes away proportional to policy, okay? Grid flexibility, self-healing, reconfigurability is very important. I will show you here in a couple minutes logic that we can put on the distribution part of the grid, where I can automatically detect the fault, locate the fault, isolate the fault, and restore service upstream and downstream of the faulted segment, all within a minute or two, all automatically, okay? And that's called an application called Fault Detection, Isolation, Restoration, FDIR, or sometimes we call it FLISR, FLISR, Fault Location, Isolation, Service Restoration. I will show you that in a little bit. By the way, and I'll get to this, but another fellow and I, we teach a full day tutorial at IEEE PES meetings on advanced distribution management systems. And we go over all these applications like FDIR in the tutorial. Also, that tutorial is available in the PES Resource Center. One time when we gave it, it was recorded, the full day tutorial. It's 5 PowerPoint files that talk about distribution automation and advanced distribution management systems. Electric power distribution infrastructure resiliency. The term resiliency has become very important because we have so many extreme weather events around the world that really stress the electric grid. And when we architect things for the grid, we focus on reliability, we focus on redundancy, but the real test of how well we did was when an extreme weather event occurs and it really stresses the grid. How many people are without electricity? What's the duration of the outage, right? How well did the grid withstand the stress? And then I will talk here in a bit about big data. So I want to mention a third book that I've been involved in. I wrote the first chapter of this book. It's called Big Data Application in Power Systems. And we just published that book a couple of years ago. And I wrote the first chapter called A Holistic Approach to Becoming a Data-Driven Utility. So one of the things as students is we are hiring data scientists now at companies, both electric utilities as well as vendors like GE, because so much of what we do is based on data. It's based on data science. So we hire data scientists and teach them about the grid, and they help us put applications, new analytics together. Okay, and I'm gonna talk a little bit about that. But I've just been mentoring a young woman from India who has a master's degree from Virginia Tech in power, and she just finished a master's degree in data science from Arizona State University. Dynamite combination today, very unique combination. When we hire a data scientist, they have no idea what the grid is. We have to teach them about the grid. And no power engineer really has much background in data science today. But this is a need that the industry has. Data science and domain knowledge of the power system. So I'll talk more about big data. Automation systems today have cloud components, public cloud components, okay? And when we architect an EMS for generation, an energy management system, an EMS is a SCADA system for generation transmission. A DMS or ADMS, advanced DMS, is a SCADA system for distribution. And they all have some amount of cloud components. And then I wrote an article some years ago on the greater use of social media. When I have an outage at home, my electric utility expects me to call them, okay? But I would rather use social media, right? In fact, over 70% of utility customers would prefer to use social media. So I would prefer my utility to have my Twitter handle in my customer record. And I would send them a tweet with outage information. Okay. And I wrote in this article, I wrote that at GE, we took tweet information from customers, keyword searched it, parsing the words, intelligently keyword searching, and we extracted the outage information from the tweet with no human involved and put that information in the outage management system at the utility. Okay. So I would prefer, I send a tweet to Georgia Power because I live in Georgia. I live in Atlanta. Georgia Power is my utility. Georgia Power gets the tweet and they see my Twitter handle and they can bring up my customer record and they know my property address. Okay. So I wrote a very detailed article about how this would work. And then the last thing is, and I'm going to talk more about this, to have effective enterprise data management throughout the utility, holistic, right? Company-wide, we need to bring the operations, the OT, operations technology group, and the IT group, information technology, together. Typically, these two groups are very different cultures and they don't work well together. In fact, in many organizations, there's a disconnect between operations and IT. And you know, we need to bring these groups together. And you guys know, you know, when I give my talk about how to build and lead a volunteer organization, one of the examples I give is how we bring together the IT group and the OT group in an organization, right? Take a few people from IT, give them temporary assignments in operations, take a few people from operations, give them temporary assignments in IT, and keep doing that, and eventually in time, the two groups will come together, okay? So let's look at smart grid concepts. And this is the IT-OT convergence. It's so important that I wanna, you know, continue emphasizing how important that is, because I've done many projects with utilities where I had valuable information on the operations side and I extracted it. I wanted to bring it over to the corporate side to an enterprise data mart. And the IT group at the utility didn't want to support the project, okay? They didn't get along well with operations. So this is very, very important. We want to integrate the electrical and information infrastructures. So these are comprehensive solutions. Remember two key words: holistic solution, okay? We want to improve the utility's reliability, their operational performance, productivity of the workforce, increase energy efficiency, decrease carbon emissions. So part of the business case with smart grid is always environmental, right? Minimizing the amount of carbon dioxide we send to the atmosphere. Now, a couple new things we're doing: empower consumers to manage their energy use and save money without compromising their lifestyle. So this is what we call in-home enabling technology. We help the homeowner with technology. I have, you know, intelligent thermostats. I can set up my thermostat with a GPS on my smartphone, my thermostats. So when I leave home and I get a certain distance from home in the summer, the temperature at my home goes up 2 or 3 degrees. Why keep the house cool when nobody's here, right? So it saves money on air conditioning. And then as I come home, when I'm so many miles close to home, that temperature changes back to what it was before and begins cooling the house back to you know, the regular temperature. So there's so much technology today, and using Alexa, right, to command temperatures, lights, you know, even my granddaughter. Some of you have seen a photo of my granddaughter. Had her 10th birthday on Monday. We celebrated her being 10 years old. And when she was younger and misbehaving, her father, my son-in-law, would use Alexa for timeout. You know, when a child is bad, they go into timeout. And so my granddaughter was misbehaving and my son-in-law said, "Alexa, start the timer, 10 minutes. Okay. And my granddaughter knew exactly that she would be going into timeout for 10 minutes and she didn't want to do that. So she yells out, "Alexa, cancel the timer." So this showed me that you know, no matter how young kids are, they keep up with technology with their parents, okay? But Alexa is very powerful, and I see Alexa being used over and over again to control energy use in the home. And then we'll talk more about integrating renewable energy at the transmission level, distribution level, and the end use customer level. But I want to finish this slide with the very bottom here. There's much more focus on the distribution part of the grid. For every dollar we invest, we get $5 to $6 back. So it's a very, very attractive benefit to cost ratio. Okay. Now, 12, 13, 14 years ago in the industry, all of a sudden this term smart grid started to be used. And people like me, I've been adding intelligence to the grid for almost 50 years with the work that I do. So, you know, I said, hey, wait a minute, this isn't the new concept, this smart grid stuff. So I said, let's call it smarter grid. And let's acknowledge the fact in light gray here, what I call old grid. This is the stuff we've been doing for many, many years, okay, in terms of adding intelligence. Shaded in light green here is what we're doing new. All right. So again, I could spend like a full day just on each of these boxes, but let me just highlight a couple. There's so much detail here about what we're doing today on the grid, but I don't have the time to go through it all. But we'll highlight a couple boxes. Like in the bottom here, I've shaded voltage control halfway. And the reason is, going back, you know, for many, many years, we've been controlling the secondary voltage for an electric utility or even an industrial customer for a long time. Why is that? Voltage is directly proportional to load. And let's say it's a summer peaking utility or summer peaking company, and they do not want to exceed their previous peak because they might get financially penalized. So what we can do is we monitor the load, and as the load is increasing towards the previous peak, we lower the secondary voltage. Voltage is directly proportional to load. And when we lower the voltage, we lower the load, okay? Likewise, when we control the capacitor banks and the voltage regulators on the distribution feeders, we reduce losses, right? That's reactive power control or power factor control or VAR control. We've always done that separately. The problem is, though, these two, when they're done separately, they can negate, eliminate, reduce the benefits of each other. When I switch a capacitor bank on a distribution feeder, the voltage rises at that point on the feeder, which could be a problem for voltage control, right? So what we do today on an advanced distribution management system is we integrate volt VAR control and do them coordinated. So that's the part that's light green, is integrated volt VAR controller, IVVC, or sometimes we call it volt VAR optimization. We'll talk more about renewable generation. Let's go up here to sensors. See, sensors is shaded halfway. We've been adding sensors to the grid for a long time. The challenge today is we have new specialized sensors that give us much more information. And utilities now have adopted what's called an observability strategy. Observability means what information in my service area can I see at the control center? In other words, without having to get in a truck and go out in the field, what is observable? What is observable remotely? Okay. And what utilities find is there's areas of their service area that aren't observable or aren't as observable as they should be. They're not getting all the data that they need. Remember now, when they buy an analytic or an application, that application can only optimize what it knows is happening in the grid. If we don't give an application enough data, enough input data, or the right input data, we're limiting the benefits that it's going to provide us, right? So data is extremely important. And this, I'm showing a specialized sensor here. This one, what I would do is take the oil from the main tank of the transformer, and I would pipe it through this sensor. And this sensor can detect dissolved gases in the oil. That's called DGA, dissolved gas analysis. Because with maintenance today, we don't wait anymore for something to fail, right? We want to collect health information on the asset, transformer, circuit breaker, and predict failure modes. We want to predict that a problem is going to occur and prevent a failure from occurring, right? We used to react. We used to be reactive. Wait till something failed and then we react. That's kind of crazy, right? Something's failed, something's exploded, something's destroyed the substation, the transformer's been, been on fire. Why not, get health information with analytics and predict failure, detect problems, and then address those before a failure occurs. So that's what we have sensors today that can detect up to 9 different gases in the oil of the main tank of the transformer. This is really powerful. If I see methane, that's a certain failure mode that's occurring. If I see ethane, it's another failure mode. If I see acetylene, it's a third different failure mode. There's up to 9 different gases that we look for. Okay, very powerful. Dissolved gas analysis, DGA. We'll talk about distribution management. This is the SCADA system for distribution. Then we'll talk about the feeders downstream of the substation. We call that distribution automation. We'll also talk a little bit about smart meters. So there's a lot going on. This is a fun slide because there's so many new things that we've been doing in the last 10, 12 years. That's why I don't want to retire. There's too much fun now, too many new things going on. I'm having more fun now than I did when I was younger. So these are 6 holistic solutions that have a very strong business case for customers. Okay, and let me go through these. Now, the next slide, I'm going to show you the technology roadmap for all the components that it takes in the enterprise to support these solutions. But for now, we'll stay at a higher level. So first of all, of these 6, the one that has the strongest business case today is this one, distribution optimization. Probably the second strongest business case is asset optimization. Because of what I just said was, instead of having an asset fail, there's a lot of emphasis today and a lot of benefits on 2 things: remote monitoring and diagnostics. We call that M&D, monitoring and diagnostics. And the second thing is we use that information for what we call APM, asset performance management. Okay, very, very important. This is where I'm going to talk in a minute about this, but this is something that's really cool. This is part of the journey to digital transformation. This is where we're using artificial intelligence, we're using machine learning, the concept of the digital twin to do a much better job of asset optimization. We talked about that in the book we did, Big Data Application and Power Systems. And I'm just reviewing now 82 papers for a conference in October in the United States for the CGRE Grid of the Future. And I just submitted 80 abstracts to CGRE Paris for the Paris session next year. I have papers on artificial intelligence and machine learning applications in asset performance management. So this is a whole new field here under data science, applying data science to the power system, to the grid. So with asset optimization, we started with transformers because the transformer is a multi-million-dollar asset and a very critical asset in the grid, right? If we lose a transformer, we lose a couple $1 million. Then we've moved to high voltage and medium voltage circuit breakers, okay? And I give separate talks just on asset performance management because there's so much that we're doing and bringing data science together with domain knowledge of the grid. Second is demand optimization. Here we're aggregating customer load and we're actually using that as a dispatch tool in the control center with an EMS. SCADA system for generation and transmission, we call an EMS, an energy management system. Professor Saki Smiliopoulos and I, for 25 years now, we've been teaching a 3-day continuing education course at Georgia Tech called Modern Energy Management Systems. In fact, we'll be teaching it in November again. And we go through all the applications on an EMS, including how we can use aggregated load as a dispatch tool in the control center. So instead of ramping generators up and down, we can pull the trigger on some aggregated load, which many times is less expensive and more efficient for the grid. Okay. Third is continuing to implement smart meters and the two-way communications with smart meters. Now, communications is the enabling technology that allows us to automate. Remember that. Communications is the enabling technology that allows us to automate. When I was an undergraduate electrical engineering student and I was specializing in power and preparing to continue to go to grad school and get my master's degree in power, I realized that communications is something that is foundational to power system automation. And I realized that I needed to study and know communications extremely well. Okay, so power system automation is, the foundation for smart grid is communications infrastructure and IT infrastructure. So this is where I say, before you think about smart grid, make sure you have a strong grid. Okay, strong grid before smart grid. You wouldn't build a house on a concrete foundation that had big cracks in it, I hope, because you built your house and all of a sudden your house falls apart because your foundation was not strong. Okay, similar with the grid. You want a strong grid before a smart grid. Don't start buying a bunch of new applications and implementing them on the grid if you have a weak or not a robust enough communications infrastructure, because you won't meet the performance requirements of the new things that you're buying. Your underlying communications infrastructure isn't robust enough, or your IT infrastructure, your OT and IT groups have a disconnect, which means that you have valuable information on the operation side you can't get across to the corporate side to share with other people in the utility. So communications here is extremely important. Okay. Then distribution optimization. We're going to talk a lot more about that because this is the focus area today, is distribution. Transmission optimization. One of the things we're doing there is much more use of synchrophasers. If you've heard of synchrophasers or phasor measurement units, the typical data we use in SCADA, in supervisor control and data acquisition, or SCADA, is 2-second, 4-second, 6-second data. In other words, we'll get what we call operational data to the control center at most every 2 seconds, but typically every 4 to 6 seconds, maybe 10 seconds. Problem is, we don't have enough granularity. We don't have enough detail at that sampling rate. Now, we started with transmission part of the grid. When we implement phasor measurement units or synchrophasers, we're getting 40 to 50 samples per second. Okay, 40 to 50 samples per second. And that gives us so much more insight into, for instance, transient stability. We can't use SCADA data for transient stability. We don't have a fast enough sampling. But synchrophasers gives us much more insight, much more ability. So we've started implementing the benefits of synchrophasers at the transmission level, because that's where the biggest benefits are. And one of the first things we did was we brought the phasor measurement unit information into the state estimator application on the energy management system in the control center. And then lastly is workforce and engineering design optimization. You think about the workforce in most countries. Let's take the United States, and I bet you Bangladesh, Malaysia, other countries are similar. In the next 5 years in the energy industry in the US, and this is true, okay? 40% of the employees, not just the engineers, but all the employees, 40% of the employees and 60% of the executives will retire, okay, in the energy industry in the US. And I think it's similar in many other countries. Remember now, when I took over as president of PES in 2006, I said, what is the average age of the PES member compared to the average age of the IEEE member? When I took over as president, the average age of the PS member was over 50 years old, average. The average age of the IEEE member was about 42, okay? We knew we had to do something to attract young professionals and students. And so that's when we surveyed, you know, a number of students, third and fourth year students. And we said, what are the three most important things to you when you graduate from the university with your first full-time engineering job? And it was very surprising for us older people. The first thing was, I want a job that's helping the environment. Second, I want a job that's helping society. Whoa. Third is, I want a job that's paying me good money and in a location where I want to live. When I graduated, it was one thing. How much money am I going to make and where am I going to live? You know, so we said we need to focus PES on helping the environment, helping society. So that's when we started the plans in 2006 and 2007, and we officially changed the name of PES in 2008 from Power Engineering Society to Power and Energy. And we added the word energy on purpose to emphasize the focus on society and environment. And if you look at the growth of PES, it started when I was president, 2007, and it's been a very steep curve to over 40,000 members. We used to be the third largest society. We're now the second largest society in all of IEEE. 39 societies in IEEE, and PES is second largest. So we really need to be in tune with what young people, you know, students, young professionals, what's important to them, and really make sure we're doing the right things, okay? Now, the other thing is with workforce, what we do after the university, when we start working, what we do is an art. It's not a science, it's an art, okay? When you're a student at the university, you learn the science with the textbooks. When you graduate and start working full-time, you spend time then with experienced people and you learn how to apply the science in the real world. You can't learn the art overnight. You can't learn the art by reading a book. You have to be mentored, okay? Mentoring is extremely important. I can't emphasize that enough. You need to choose one or more mentors and experienced people that can help you learn how to apply the science in the real world. Otherwise, you're limiting yourself in your career. You will only know the science, and it will take you many, many, many years to learn the art on your own, okay? And so it's very important to spend as much time as you can on a regular basis with experienced people that can help you. Okay, so workforce, that's why I'm spending a little bit more time. Workforce to me is very important in standard engineering designs. So anyway, let's take these 6 solutions and let's look at the technology components here around the enterprise to support them. So in the upper left here is the officer control center. Lower left is the substation. Then we have the equipment on the feeders. Okay, so let's look at these light blue boxes here. This is the distribution optimization. So these are software applications, these 4 in the upper left, that sit on a DMS, a distribution management system. Then we have the outage management system. Lower left is a substation. We have applications that run at the substation level. So we're distributing the intelligence. The intelligence doesn't necessarily all run at the office anymore, the control center. We're distributing it down to the substation level. And then the equipment here on the feeders, the switches and breakers and the volt var devices, those support the logic. the switches and breakers support the FDIR logic, fault detection, isolation, restoration. And the VolVAR devices, these are capacitor banks and voltage regulators, support the integrated VolVAR control logic. Now that logic can be running at the control center or at the substation level, okay? So think about these blue boxes. These could all be from different vendors, but they all have to communicate with each other successfully and exchange information successfully, and that's a challenge. That's why industry standards are so important. That's why, I got involved in standards with IEEE 35 years ago. Standards is extremely important. We all need to know the relevant industry standards. I'll spend some time on that at the very end. So there's 5 key components here with the distribution part of the grid. Smart meters, the two-way metering communications, we call that AMI, automated metering infrastructure, the geographic information system, the outage management system, and the distribution management system. How well these are integrated together is really a measure of the resiliency of that utility's grid, okay? Now, smart meters, in addition to meter readings, we get the voltage from certain smart meters at the ends of certain feeders. We ping those meters to get the voltage and put it in the distribution management system. When we're doing VolVAR control, we got to make sure the voltage at the end of the feeder is within the limits for that country. In the US, the voltage at the customer must be 120 plus or minus 5%. So we got to be careful. We can't be too low voltage at the end of the feeder. Geographic information system is the reference system for the network model. And then with customers, I mentioned we want to move from phone calls to social media. So when we designed the distribution part of the grid, we designed it for one-way electricity flow from source to load. And it was always that way, right? When a field worker from a utility goes out to do some work, they felt that all they had to do was open the upstream device and they had a de-energized situation and a safe working situation. That's not true anymore with the integration of distributed generation. The industry challenge now is we have two-way electricity flow, okay? Because when we start integrating distributed generation downstream of the substation, that causes two-way flow. So we can integrate renewable energy at the transmission level, distribution level, or the end user level. Some of the challenges though, let's look at distribution. We could have open circuit over voltage due to unintentional islanding. Let's say a microgrid islands unintentionally. We could have protection ratings that don't match fault currents, right? And the reason is when we did the protection settings, the first step is you do a short circuit study. You need to know the magnitude of the fault currents to set the relays. But when we modeled the grid, we only modeled it for assuming electricity flowing in one direction, and the contribution to the fault would be from the source side only. As the penetration of renewable energy grows, we could have a significant load side contribution to the fault. But even more challenging is that load side contribution from distributed generation varies, varying fault currents due to distributed generation. Is the sun shining all the time? No. Is the wind blowing all the time? No. So the intermittency of the distributed generation causes the fault currents to vary. Very complicated situation, okay? And I'll talk more about voltage regulation equipment in a minute. This is a microgrid that we installed in a rural village in Canada about 5 or 6 years ago, we at GE. So think of, here's a village, not near any utility, on their own. They have industrial load and residential load. They have hydrogen fuel cells, some solar generation, some hydro generation, and typically the base generation is diesel, okay? Now, we want to minimize the use of the diesels because they emit carbon dioxide to the atmosphere, and the diesel fuel is very expensive to get it to a rural village, the transport costs, okay? So we took a microprocessor-based relay in the upper left here, a U90 protective relay, and added logic to it to become the microgrid controller, okay? And all, we said we need to satisfy the load continuously, but we want to maximize the use of the hydrogen fuel cells, the solar generation, and the hydro generation, minimize the use of the diesel generation. And these blue boxes here are high-speed communications equipment, so we know what's happening around the grid continuously. Okay. Now, I said there's intermittency, right, with the sun and the wind. When you have electricity at home, if the sun's not shining, you still want electricity though, right? And if the wind's not blowing, you still want electricity at your home. So how do we bridge that intermittency? Well, one is with energy storage, right? With batteries, we can do that. And storage is good for fast, it's instantaneous, right? It acts fast. But what if something is needed over a longer period of time? Well, today we have thermal generation that's fired with natural gas that is very fast starting and fast responding. So you see new technology today to support both instantaneous needs and longer time needs with respect to intermittency. And in fact, at GE a couple of years ago, we announced an electronic gas hybrid turbine, which is 10 megawatts of lithium ion batteries and a 50 megawatt natural gas fired turbine generator that is an integrated package that works together. Software optimizes the operation of both combined. Okay. Now here's an interesting, this is where I talk about voltage regulation concerns. And this is very real. I wrote this article. This article is available online. You can search on the internet, Power Electronics Magazine and my name, and you'll find this article. It's really interesting. This is a distribution feeder along the Pacific Ocean with San Diego Gas and Electric in California. And as you know, probably there's a tap changer in the substation of a distribution feeder. And the online tap changer is a mechanical controller, and its job is that as the primary voltage fluctuates, you want to keep the secondary voltage constant, right? You want the light bulbs in your house not to be real bright and real dim and real bright and real dim as the secondary voltage changes. You need that secondary voltage to be constant, and this is done by the tap changer. So the tap changer has 16 raised positions, 16 lower positions, a neutral position. And as the primary voltage fluctuates, the tap changer automatically changes taps to keep the secondary voltage constant. So you can see the more often the tap changer operates, the less lifetime it has because it's mechanical, right? It'll wear out. So in this substation in San Diego, the tap changer was operating about 5 to 10 times per day. All of a sudden, policy changed in California, and many homeowners put PV panels on their roof, photovoltaic panels. In fact, over 35% of the homes on that one feeder had rooftop solar panels. In the morning, because of the Pacific Ocean, there was a marine layer of fog over the homes, from the moisture in the ocean, a marine layer of fog, blocking the sun's rays. As that fog burned away in the morning, all of a sudden, all the homes began generating at the same time. The voltage on that feeder, with over 35% of the homes generating, the voltage spiked like a rocket. And then it oscillated. And this poor tap changer is trying to keep the secondary voltage constant. It's now operating over 120 times per day, okay? And its expected lifetime went from 35 years to less than 2 years. It would have to be replaced, okay? So I wrote this article in Power Electronics Magazine 8 years ago, okay? And the reason I wrote it in Power Electronics Magazine, I said there's new applications of power electronics. One would be a substation transformer online tap changer, power electronic based, not mechanical anymore. Second is low voltage network dynamic grid edge controllers. We're further distributing the intelligence, and we're putting low voltage power electronic based grid edge controllers on the edge of the grid and smart inverters. Okay. Now, the bottom line with this is, I've been preaching this for a long time. Within universities, I want to see the power electronic students, graduate students, and professors work more closely with the power system students and professors. We have needs of power electronics, not high voltage power electronics, but low voltage power electronics. We have needs in the grid, okay? So this is something, another research area which is very important, which would be somewhat new, would be low voltage power electronic expertise being applied to the grid, okay? Very interesting. Now, again, another fellow and I do a full day tutorial on this for IEEE PES, but this is the centralized control model for a distribution management system. You have the basic SCADA server. This is supervisory control and data acquisition. And then you have all the applications on the distribution management system to optimize the distribution part of the grid. I said the reference system for the network model was the geographic information system on the left here. And on the right is all the field equipment and substations and feeders. Obviously, it's bringing real-time information into the SCADA system. And then that's being used by these applications. And then when you optimize the grid, you send control commands out to the field to make changes for optimization. Now, in a DMS, there's 3 groups of applications on a DMS. This is the group of real-time applications. So these are running all the time that the operators use. And then in the tutorial that we do for a full day, we go through each of these applications separately. Second is a group of analytical applications. So these are on demand, not running all the time, but on demand for certain functions. And third would be an ancillary or extra group of applications that the utility wants running on the DMS. Okay. Now, every utility's goal today is to be digitally enabled. What I say here at the top, digitally enabled. Okay. But realistically, no organization can go from where they are today to that target in one step. It's just not realistic. There's not enough money available, not enough people, resource available. So what we do is we work with customers and say, how can we put a roadmap together, a series of steps to get to the ultimate target, okay, realistically. And so let's take a look at this utility here. Currently, it's manual control and legacy methods. So it has a manually operated network and a static view of the network configuration. Not a dynamic view, but a static view, okay? So we said, okay, whoops. Said, okay, let's, okay, so the second step here would be SCADA, trouble calls, and circuit reclosers. And that's a big positive step over manual. Let's see if I get the animation's not working. So this would be 28% benefits over the base case. Third step would be automation and visualization, which is distribution automation. We add network visualization, outage management. We call that automation and visualization. Here we're over 40% additional benefits from the base case. And then we get to fully digitally enabled with asset performance management and network optimization utilization. Here we're well over 50% increased benefits from the base case. So what we want to do is realistically put a roadmap together to help the customer. Let's see. Oh, I was going in the wrong direction, I guess. Okay, there's the base level. So the second step is 28%, as I said. Third step is 43%. So when you put a roadmap together, each of these steps should bring significant benefits to the customer. And then 50%. Lower what we say customer minutes interrupted. So here what we mean is we're improving the reliability of the distribution part of the grid, lowering customer minutes interrupted. Okay. Now, another thing, here's a utility with 856 circuits. And that's a lot of circuits, a lot of money to automate that utility. We said, well, let's study this first. And we find that only 23% of the circuits account for 71% of the total outage minutes. That's pretty insightful. So if we automate only 23% of all the circuits, we're addressing almost 3/4 of all the outage minutes. That's a much better use of money, much better investment by the utility. Okay. Now, when we first saw microprocessor-based devices in the 1980s, they were very different for the industry because not only did they give us the data that we need to send to the control center for the operators, but they gave us something I call non-operational data. Okay, that was brand new. I wrote an article in 2003 in IEEE Power and Energy magazine. That's the magazine for PES members. And it's a 10-page guest editorial. And I introduced these concepts to the industry for the first time, the concept of operational data and non-operational data. So operational data is real-time data that its points. It's the fundamental information used by the system operators. Things like current, voltage, real and reactive power, alarm information, open, closed. The non-operational data is points or data files. The primary user is someone other than the system operator. And actually there's 25 to 30 groups in the utility that have a use for this data. Okay, it could be protection, it could be asset management, it could be maintenance, it could be planning. Okay, and this is on demand. So if we compare the two types of data, operational is individual time sequenced at the scan rate of the SCADA master. Typically, operational is real time, and it's also, we use standard communication protocols to transmit it. Non-operational is points or a file, mostly historical. And if it's a file, we may need to use the device vendor's proprietary format to extract it. Okay, I'm going to get back to this in a minute, but remember operational and non-operational data. One of the things, truly the productivity revolution that we're in the middle of today is the Internet of Things. We're bringing together intelligent machines with big data and analytics with people at work. So we're connecting people any place, any way, anytime for intelligent operation. And this is why communications is so key today, right? The question is, how do we leverage this within our own organizations to save money? Well, let's go back to think of the Internet of Things, but also think about the operational, non-operational data. On the left here is a typical utility today that's very siloed. Each group has its own systems, its own IEDs or devices, and its own repositories or databases. There's no sharing, so it's not holistic. It's not enterprise-wide. It's siloed by group. Okay, and this is very typical, which means that a lot of the data that's in these devices and systems it's not being shared. It's not being utilized. There's a lot of up in the top here, there's a lot of non-operational users that don't have the data that they need. So on the right here, what we do is we break down those silos, put in a federated data mart, okay, to bring together, to map and bring together all the data sources with all the users with data needs. Ideally, you want all the operational and non-operational users to have all the data they need from all the data sources in the enterprise. Okay, that's the goal. So what we have then on the left here is this is a standard substation automation architecture with a master data concentrator and slave data concentrators collecting data downstream of all the devices. On the right here in cyan, the color cyan or light blue, we would list all the data sources in the enterprise. And in green here is all the different users, both operational and non-operational users throughout the utility. Want to make sure that all the data needs that they have are met. Okay, so this is really, and I say this, if I was a student or young professional today, I would print this slide and I would post it in my computer room, my office, where I did my homework or where I did my work, because this is the future and this is what's so exciting today. Remember I said that this is the journey to digital transformation. You can see many utilities today, and their goal is to be have a fully digitized grid. Okay, some of it is the substation of the future. We wrote an article in Power and Energy magazine just a couple of years ago on the substation of the future, a fully digitized substation. But what's cool about this is, you know, we started with reactive. As I said, we waited for things to fail. Then we went to responsive, and today we're just barely at predictive. We're learning what health information we need from assets, how to use artificial intelligence, how to use machine learning, how to be able to predict more failure modes of the asset. Well, ideally, we want enough health information that we can predict 100% of all the failure modes that asset could have, right? But what's cool about this is we're only halfway on the journey, okay? We still have so much more we can do. Prescriptive and then autonomous. Autonomous is fully self-healing, self-provisioning, and extensive autonomous operation with limited human intervention. Again, more artificial intelligence, more machine learning, more bringing together data science with the domain knowledge of the power system, okay? And more use of the digital twin. This is the future. And it's the combination, as I said, of data science with domain knowledge of the grid. We've applied this already to asset performance management. And there's so many other applications that make sense, not just in the power industry, but in many other industries also. Okay. Let me finish here with a little bit on standards and then some lessons learned. So we developed the Smart Grid Conceptual Reference Model, which is these 7 domains here and how those domains interact with each other. So with the initial talk about smart grid, people said, well, wait a minute, smart grid seems like it goes forever. What isn't included in smart grid, right? At GE, we say smart grid is from turbine to toaster. Think about that, turbine to toaster. Power plant to your home, right? That's generation, transmission, distribution, and commercial and residential customers. If I gave you a sheet of paper and a pencil and I said, draw all of smart grid on one sheet of paper, what would you draw? Well, this is what we came up with, was this conceptual reference model of 7 domains and how they're the secure communication interfaces. We're actually on the 4th version of this diagram in the US. I was one of 11 smart grid experts that selected by the US government. And we published earlier this year version 4 of the smart grid requirements for the 10 to 15 years in the future for the United States. Okay. And that's public information. But one of the things that I chaired a board for 5 years for the United States on coordinating all the smart grid standards work for the US. And you know, IEEE has over 100 smart grid standards. The IEC has over 100 smart grid standards. How does somebody in industry figure out what standard is important for the work that you're doing, right? Nobody can go through hundreds of standards. Well, we did this. We wanted to help the industry. So the 25 of us on the Smart Grid Interoperability Panel was a board that I chaired from 2010 to 2015. We came up with this set of foundational standards for smart grid. These are 16 standards. They're the most important industry standards for smart grid, whether it's generation, transmission, distribution, or the end use customer, whether it's cybersecurity, integrating renewables to the grid, software in the control center. One of these 16 standards will cover all those areas. Okay, so this has really helped the industry quite a bit. Okay, and what's really, you know, in 35 years of doing smart grid standards work, if we look at control center to control center, there's one worldwide standard, only one worldwide for one control center to exchange information with another, and that's called ICCP, Inter-Control Center Communications Protocol. From control center to field equipment, it's either IEEE 1815, which in North America we use a lot of, called the Distributed Network Protocol 3, or if it's a European supplier, you'll see IEC 870-5, 101 for serial communications and 104 for network. So we have control center to control center, then we move down to control center to field equipment, and now within the field, IEC 61850 is the worldwide standard, no question about it, for substation automation and protection. But within North America, we still use a lot of, again, of DNP3 or IEEE standard 1815, okay? Now, after 18 months of deploying smart grid projects, I'll finish here with a few slides that we actually stopped after 18 months and we reflected back and we said, what were our initial assumptions? What did we learn and what changes will we make going forward? I actually wrote an IEEE Smart Grid newsletter in July of 2011, and it's posted on the IEEE Smart Grid portal called Lessons Learned in Deploying Smart Grid Projects, okay? Now remember, a holistic solution is a set of technology components. Remember we went through all those light blue boxes on that one slide. What's very important with a holistic solution is the maturity of the technology components, okay? The solution is only as mature as the least mature component. So we found the component technology was not as mature as advertised when combined to create a smart grid solution initially, okay? Because some of this technology was new. Think of a chain, right? When you pull a chain tight, the chain is only as strong as its weakest link, right? So it's the same with a holistic solution here. You really want to test all the components and make sure of the maturity. Second is industry standards. Two other key words in the industry today are integration and interoperability. We have to adopt and insist on standards and open architecture. Third is testing. Not only testing in the factory before we get to the field, but what we say end-to-end testing, from the device in the substation all the way up to the control center or the office, okay? Now, project management is key. And each project manager for each smart grid solution must have multidiscipline authority, okay? A smart grid project involves many different groups in the organization. And when you're the project manager, you have to have authority over all those groups. There's a difference between having responsibility to do work and having the authority to be successful with your work. Responsibility is easy. Authority must be given to you to be successful by your manager, okay? We found initially projects where the project manager had responsibility, but didn't truly have the authority to be successful, okay? So what we found was at GE, we could provide the best equipment in the world to the customer. The customer can have the best engineers in the world, but the project can fail. And it can fail if there's a weak project manager. So we said we need to build an A team with the customer, with the very best project management people and technical people, both. Not just engineering people, but project management people. Project management is key, okay? And then lastly is what's very important, and this was new to us, okay? New to us that have been in the industry for a long time. My expertise was always upstream of the meter, right? Most of us, our expertise was on the grid. All of a sudden with smart grid and installing smart meters, we found that the residential commercial customer was now a major stakeholder in smart grid. We had never, ever engaged with the end use customer, right? All we had done was read the meter on somebody's house and generate a bill for them to pay the bill, but no one ever talked to them, right? No one ever had to. And now we found with smart grid and technology, in-home enabling technology, the residential commercial customer is a major stakeholder. So 11 years ago, I'm a founding board member for an organization called the Smart Energy Consumer Collaborative. We have about 180 members, and we focus on research and education of the customer, the residential commercial customer. Okay, so think about, to be complete with smart grid, you can't just focus only upstream of the meter. You have to really think about customer segmentation, right? Customer education, that's very important. That's an important part of smart grid, right? So let me finish there, and I'll stop sharing. I know that's a lot of information, but that's a good update on some new things that we're doing on the grid. And let me turn my speaker back on.
100%.
So I want to see if my speaker is working. Somebody speak.
Hello, sir.
Okay, good. I can hear you. Yeah. Whoops. Should I go through the questions in the chat area first?
Said
yes, sir,
will
we have
be
some questions.
conducting that. Yeah. Can you help sir to read out the
Yeah.
questions?
Yeah, I'm helping. Sorry, I had some mic issues before. Okay. Okay, the first question. Okay. We have some comments also, sir. Cool, big fan of Tesla. Okay, that was before. Okay, the first question is, sir, you spoke about reducing the voltage to reduce the load. To which level? Is it safe to reduce the voltage below the rated value?
No, you don't want to do that, and that's why we when you do volt-var optimization, what you do on the distribution feeder is you flatten the voltage and then lower it. Okay, and you want to be very careful. If you have a long distribution feeder with a lot of voltage drop, you could have a danger of very low voltage at the end of the feeder. So what's very important is each country has a standard. Okay, as I said, in the United States, we have ANSI standard 84.1. ANSI is American National Standards Institute. And it says the voltage at the customer must be 120 plus or minus 5%. Well, 120 minus 5% is 114. So we put a minimum on everything we do at about 116 to give us a margin. And we make sure that when we reduce the voltage and we do volt-var optimization, that we have a buffer, right? A margin. We don't get close to, we don't even get close to the lower limit. And we would never want to reduce the voltage below the minimum. What happens is you have problems then with loads. Some may drop out. If the voltage gets too low, motors will stop spinning, motors will drop out, and some loads will drop out also. So no, it's not safe to reduce the voltage below the rated value.
Thank you so much, sir. This question was from Mashroon Adib. So I have another question from Mohammad. No, that's Mohammad Hafizi. Okay, sir. Okay. Yeah. Sir, what is your opinion on wide area applications in the future, such as for control, protection, false location, etc.?
That's really what the trend is. Truthfully, it is. It's a wide area application. So one thing with phaser measurement units, the phaser measurement unit, I didn't mention this, but the phaser measurement unit information, what we do with that information is we build a wide area measurement system. You might have heard of these or read about, it's called WAMS, W-A-M-S, okay? We also have what we call special protection schemes. It's an industry term called SPS, or another industry term called RAS, remedial action schemes. And these are wide area applications that utilities run constantly. And they look for trigger points. For instance, if the circuit breaker on this transmission line tripped, there could be an unstable situation with the grid. So a remedial action scheme then would start executing its logic. And that's a wide area application with high-speed communications that ties equipment together over a large geographic area. So you know in real time what the current state is. And what you do is you make switching decisions. You make decisions on the grid to keep the grid stable. So we actually have a number of wide area applications today, and developing more. So this is really that's why communications is so critical, because on a wide area, a large geographic area, right? It's more challenging to know what's happening in real time because you have a large geographic area. You need higher speed communications to bring all that data together, you know, over a large geographic area. So that's why communications is so key, and high speed wide area communication is so important. So that's really what we're doing today and what we'll be doing in the future.
Thank you, sir. So we have another question from Farhan Tahmid. Is using smart meters worth the investment of the grid companies? If yes, in which way and how long it takes to obtain the return of investment, ROI?
Well, how long it takes to obtain return of investment, or what we would call the payback period. You know, with every investment, you want to know, when does the cost curve, right, cross the benefit curve, the anticipated benefits. And that crossing point is the payback period, or the number of years it takes, right, to obtain the return of investment. And that really depends on each utility. So it's very, very different with each utility. So it's hard to generalize what that is, but let me give you an example of why smart meters are worth the investment. Some of the initial deployments of smart meters were in countries where there was a lot of theft of electricity, okay? For instance, we have what we call in the grid, we have technical losses, and we have non-technical losses, right? Technical losses are like heat, you know, caused by impedance, the resistance of the conductor, right? Those are technical losses, and we can measure those, right? Non-technical losses are things like theft of electricity, okay? In the 42 countries in Latin America, the average non-technical losses was over 20 to 25%. So think of 20 to 25% of the generation of electricity never made it to the customer because it was it wasn't being paid for, right? It was being stolen. So smart meters have what's called tamper detection. Okay, so think of it, a smart meter has two-way communications, but also has tamper detection. You know the word tamper, English word T-A-M-P-E-R. If tamper means somebody is fooling around with the meter and trying to steal electricity. So if somebody breaks the lock, takes the meter out of its clamps, maybe turns it upside down to reverse it, or tries to change it. That's the English word is tamper. You're tampering with the meter. So smart meters have tamper detection. As soon as the meter is being tampered with, it immediately communicates to the utility, because remember, it has two-way communications. It said somebody is messing around, somebody is tampering with the meter. So countries that had in India is a good example, countries with high non-technical losses had a very fast return on investment by employing smart meters, because it decreased substantially their theft of electricity, right? It tremendously lowered their non-technical losses. And that was a tremendous, not only savings, but a tremendous increase in revenue for the utility. And you can see where that would pay for the meters very quickly. So that's one example. So yeah, smart meters also give us, as I said, voltage, right? Which we use in a distribution management system. I didn't mention this, but a smart meter has last gasp communication. So let's say it's a smart meter with two-way communications. All of a sudden, there's an outage, right? Right as the outage occurs, a smart meter has a capacitor in it. And when that capacitor is charged, there's enough energy for one final communication from that meter to the utility. So think of this. The utility, when they put in smart meters, they don't have to rely on customers calling them to say that they're out. Every smart meter reports as soon as there's an outage. Every smart meter says, hey, I just had an outage and this is the time it occurred. So the utility knows all the customers that have an outage, the time it occurred automatically from the smart meters. So that you can see there's significant benefits from smart meters, and the payback period can be very, very reasonable, very short. Okay.
Okay, thank you, sir. Sir, we will take some of the questions later. I would like to, it was a wonderful session, of course. Well, now it's truly an honor for all of us to be present here. Now I would like to welcome Dr. Tiago Ribeiro de Alonso, the chair of IEEE Power and Energy Society Chapter Student Activities Committee, to give the token of appreciation and closing remarks for today's event. So, sir, it's over to you.
Thank you for the invitation, and congratulations, John McDonald. It's very inspirational. Every time that I attend in one distinguished lecture provided by you, I'm so inspired, and my eyes is open more about the future. You are a great inspiration. Congratulations for the PS student chapters and IEEE student branch in Bangladesh and Malaysia. It's amazing to see the joint and collaboration between countries. And also I motivate you to make collaboration with another regions, not only Region 10. Congratulations, PS Sisaki, Malaysia and Bangladesh team to provide this joint initiative. I'm so inspired to see this joint initiative. And I hope that everyone enjoying today's session. I would like to share my screen and provide a few suggestions for the attendees about the opportunities. And also I would like to share one great news with you. But I'll start, let me share my screen with you. Only 1 second. Okay. So what I'd like to share with you is about the Distinguished Lecturer Program. I don't know if everyone know about this program, but today you are attending this session based on this program. You can find this information in the PS web page. Okay, you can go in the main web page, chapter community, chapter activities, and Distinguished Lecturer Program. This is a program sponsored by PES under the chapter organization. And in this page, you can find the list of distinguished lecturer. What's happened in the previous years, only PS professional chapter can invite the distinguished lecturer because PS provide a sponsorship to pay the travel from one country to another for the distinguished lecturer speakers. And if you are senior members or professional members and you'd like to apply to be a distinguished lecturer, also you can apply by the online form that you have here, and you can see the rulers and everything. PS always is looking for more distinguished lecturer speakers from different parts of the world. So this is a great opportunity to senior career members. But also, if you are a student, part of one student chapter now, with the distinguished lecturer, you can request distinguished lecturer speakers too. For example, this was one event driven by PS student chapters in Malaysia and Bangladesh. And if you'd like to receive support from PS CSAC, also you can request to us. We have different CSAC counter representatives. Let me share with you and how you can request that. In the PS CSAC webpage, you can find here in activities, CSAC team and CSAC team 2021. And here you have different counter representatives, and you can contact them in different regions, in region 127, region 8, and region 9, and region 10. Okay, for example, for today's session, the CSAC supported this event based on the approval from Maisha from Bangladesh and Hussein Salim from Malaysia. So if you are watching these recorded videos, or if you are in the session now and you'd like to organize any kind of distinguished lecturer activity, you can contact the PS CSAC. You can choose one distinguished lecturer, contact the distinguished lecturer, or you can contact the CSAC counter representative and request this official CSAC support. So in this way, you can promote your events globally. Okay, you can share the events globally with all the students. This session was shared with all the 10,000 PS students across the globe in the past few weeks. And we had amazing registration. Maybe Baisha and Hussein can talk a little bit more, but we received registration from different parts of the world for this session. It was amazing. And if you don't have one CSAC counter representative in your counter, because you have only counter representatives, CSAC counter representatives in counter with more than 2 PS student chapters, also you can contact the CSAC regional coordinator. Okay, and how you can contact them? By the link engine. You can open here, we have the contacts, and you can request and send message to them by link engine. Okay, this is the official way to make communication with them. And another point that I would like to share with you, in this month of September, we are organized the Women Power Day in Region 9. And also you have this program, that the PS CSAC Leadership Program. I don't know if everyone knows this program, but this is a program that you have started in 2019. And the goal of this program is to provide more leadership opportunity in country, region, and global level for the future PS leaders, students and young professionals. So how you can be part of this program? In 2 ways. If you are part of PS student chapters and you was part of the board member, chair, vice chair, secretary, any position in the chapter board member, you can apply to be a counter representative. And later, based on your performance, you can be appointed by CSAC to be the next regional coordinator. All the regional coordinators of the CSAC today was past PS student chapter leaders, or we can help you. You cannot provide you the position, but we can connect you with the local PS CSAC chapters and suggestion then to consider you as part of the team, or you can be part of the core team of PS Day. And the another way to join this leadership program is the PS Day. You can join as ambassadors, student to professionals. After that, you can be a regional leaders. Every year, we have different PS Day regional leaders, and our regional leaders was past PS Day ambassadors. And after that, you can become part of the PS Day core team. All PS Day core team members, they was past PS regional leaders or PS Day ambassadors. And after that, based on your performance, you can get more leadership opportunity in committee or technical committee. The sky is the limit to you. The PS provide leadership opportunity to young students or senior members, and you need to enjoy. This is a program that you are implementing in the last 3 years, and we have outstanding results about that. Many of the PS committee that you have, now we have young professionals and students in global leadership position or regional leadership position, and they was past PS student chapter volunteers. So I'd like to invite you to consider that. And by the end, I'd like to invite you to hear one minute talk that we had in yesterday from the PS Women Power Global Share. I don't know if the Facebook you allow, but let me try to play here. I don't know if you can listen very well.
There's no voice.
Okay, I can share with you later the video, but what was announced yesterday was that the next PS Women Power share, you'll be one past PS student chapter volunteers and also one past PS Day ambassadors. Remember that, how this leadership program helped. And the next PS Day, the next Women Power Global Share of the next year, you'll be, the current is Humei Lee, and the next year you'll be Listen. She's past PS student chapter volunteers, very, very young volunteers, and past PS Day ambassadors. And how you can get more leadership opportunity with PS CSAC. And I would like to share with you one great news that all the students will receive today by email, a new leadership program under the CSAC. We try to provide always opportunity to students and young professionals. This is the call for CSAC leadership ambassadors. All the students you receive this information and you share in the social media. This is the call for CSAC leadership ambassadors in 3 different categories: online course, members or volunteers that would like to organize online course in their chapters; PS STEP, student transition and elevation partnership. This is one of the main goals that you have for this year: improve it and increase the transition from student to young professional. And HAS for Kids. I know that it's very difficult to organize pre-university activities face-to-face, but the task for the HAS for Kids ambassadors will be to develop it or submit to us new draws for and online materials for HAS for Kids on online videos to teach kids about renewable energy. So the deadline will be September 12th, and the registration and everything you receive by email in the social media by this week. Okay, so remember, PS have opportunity to everyone. PS are looking for new leaders, and if you'd like to join us in the CSAC team, global team, this is an amazing opportunity. I hope that you enjoy this, one of the outstanding opportunities that you have in the CSAC, and you can become the next PS CSAC leadership ambassador to represent your country, your region, and increase the PS activities globally. Thank you.
Thank you, Tiago.
Okay, now we have give the token of appreciation. And Sakib, are you there?
जी भैया.
Would you please share the screen? Well, before that, I would like to call Maisha Tafanum, Chair, IEEE North South University Student Branch. Maisha, are you there?
Hi, thank you, Ridwan, and thank you everyone for joining. But first of all, let me thank our today's special guest, Dr. Shohidul Islam Khan sir, who is the chair of IEEE's Bangladesh chapter, for his opening remarks. I believe sir has dropped from the meeting, but he was there from the beginning till up to some time. So yeah, thank you so much to sir. Next, can we have the token of appreciation for John McDonald, please? So this is for our today's distinguished lecturer, John D. McDonald. Sir, a very, very big thank you to you for your amazing session. Like, you could see that we had so many questions, and I think this event has been going on for almost 2 hours. So yeah, your sessions are as usual so engaging, so interesting, and I wish all the attendees could understand why I'm sounding so excited, because I have had the chance, like some of us have had the chance to attend some of John sir's sessions where we used to talk about many stuff. So we know that how much he loves interacting with young people. And as I always say, that John sir, if your hair was just the normal color, you would just look like a young professional. We cannot believe that you are already 50 years in IEEE. So you are a very big inspiration for many of us. Anybody who gets to meet you gets inspired instantly. So thank you so much for allowing us to host you, and for being here for IEEE North South University and Multimedia University student branches and our PS chapter. So hope you like this token of appreciation. This is a very small virtual token of appreciation on behalf of the team to you.
Thank you. I love, as I said before, I love interacting with Maisha, with your team, Mohammed, the group from Malaysia, and all the leadership that you have. And I hope we can continue to do that, and I really mean that anytime you want to meet at any time in the future to talk about anything, career, technical, whatever, just let me know. I'd be happy to do it. And it's a real pleasure and a surprise to see Tiago today. I don't get to see Tiago too much except statically in Facebook and LinkedIn, but to see you live is a treat. So that's nice. Nice to see you, Tiago. And all of you, thank you for all that you do for IEEE and PES. But and I really mean this, the more you put into something, the more you get out of it. It's true. If you just come in and sit in the back of the room and let others make decisions and lead, you're not going to get much benefit yourself. You really have to jump in. Like I say, when a bus comes to you, you're going to get on the bus and sit in the back of the bus and let someone else drive. Then you're only reacting to the driver. No, not me. My whole life, I want to be driving the bus. I want to be the leader. Then I can optimize everything that I do, my family, myself, my career. I can optimize it because I know what the future is going to be, because I'm involved in making the decisions. right? So be a leader, be proactive, you know, don't react. Don't let others make decisions and you're just, then your life will be a compromise at best. Okay, don't just be reactive, but take the lead, make the decisions and help others, and you'll benefit much more. Your career will be much greater, and you'll actually interact with so many more people that way too. But anyway, I really love spending time with all of you. I really mean this, and it seems like we set a half hour, an hour, and then two and a half hours later, we're still talking, you know?
Yeah. I remember our sessions, like
It always
how 2
happens.
hours how 2 hours passes, we just don't know. So yeah,
The
thank
coffee
you.
sessions, yeah.
We love to interact with you as well. We love talking to you as well. So getting back to you, but first let me also thank Thiago. Can we have the token of appreciation for Thiago, please? So thank you so much, Thiago, for all the support, for all the support actually, from starting from the promotions to suggestions to everything. You have helped us so much. This event was also supported by the CSAT team, PS CSAT teams of Bangladesh and Malaysia, definitely, because me and Hussein, we are the country representatives, but Thiago is the chair and he has done a lot. So thank you so much for being here, for sharing so many valuable information. It's as John was mentioning, that it's a treat for him. It's a treat for us that we get to have so many great leaders in a single platform, and this has been a great opportunity for us to host you as well. So thank you, Thiago. Hope you accept this token of appreciation from us.
Thank you for the opportunity. I really enjoy, and I love it, the work and the passion that the team have worked, and to see, like I told you, I'm so motivated to see more collaboration between countries, regions, and the job that you have done, it's amazing. This GLP events also was amazing, provided by John McDonald, and I hope that you can see this kind of activity more frequently in another part of the world. Congratulations, and thank you for the appreciation. I really enjoy.
It's our pleasure. So I think Thiago has missed the group photo. So if everybody is comfortable, let us again turn on our cameras so that we can take one last group photo and capture this great moment. Okay. Sakib, can you help us with the group photo, please?
Sure, Apu.
Thank you.
And maybe just give another like 20 seconds.
Yeah. Yeah.
20 seconds more.
We can see Bruno. He is like moving a bit. Hi, Bruno.
Yeah. Yeah.
3, 2, 1. Okay, thank you, everyone.
Could you take everyone's picture? I think still some people are
Already turned off. It's
turning
okay.
on there. Yeah.
I think it's okay.
Okay.
Okay. So
We'd like to apologize because we couldn't take all the questions, and we are already passing the 2 hours. So we're really sorry for that.
Yeah, we have already passed 2 hours, but if you want to still, if John McDonald sir allows us, if you have time, then we will be addressing some more questions, or if you have time actually. So I think the lecture session is formally over, but we can carry on. If sir has time, then we can carry on the session if you want. So yeah.
I have some more time, so I'd be happy to spend some more time if people want have some questions.
Yeah, I think we
That's
still
great.
have some
I think
questions.
that's great. Yeah, okay, we can carry on the question answer session. And attendees, guys, please, as I mentioned, the lecture session is over. But if you have any question regarding leadership, regarding your volunteering or anything, you can just ask this this great speaker who is here. I think this is a very rare opportunity that we get people like John McDonald to resolve our queries. So please go ahead if you have any questions. So yeah, Said, do you want to continue?
Yeah. I'm doing that. So the question where I've left from. Okay, yeah. So he wrote, my question, I think it's necessary to have a consistent and complete cybersecurity solutions to be integrated in the whole overall system architecture. For example, in your scheme, we do not see any firewall between office and substation. As you know, a cybersecurity is a complete solution to be provided in order to ensure a safe access from any location with local network over local network, and also the servers for OS update and so on.
Yeah, well, firstly, the diagrams that I showed were very high level, simplified diagrams. Okay, so I have other talks that I give with more detail that would show all the firewalls. It would show all the demilitarized zone between operations and IT, and it would show more of the cybersecurity network. So there's no question it is necessary. Cybersecurity is very important, and it's a part of every, when we develop a product, we incorporate cybersecurity from the very beginning of product development. All SCADA systems are sent to the Idaho National Labs, one of the U.S. Department of Energy laboratories, and they have professional hackers that try to do penetration testing of the SCADA systems. Okay, they try to find vulnerabilities, and this happens with each of the SCADA vendors. Okay, the system. So we have we're doing all we can from a cybersecurity point of view to have a complete solution, look at all vulnerabilities, address all of those. And lastly, I give a talk on cybersecurity that we could do at some point in the future if that's of interest. And what I do is I do the complete anatomy of what happened in the Ukraine a couple of years ago, when hackers spent 9 months collecting information, planning the attack, then launching the attack, where 225,000 people were without electricity, and 3 distribution utilities, their SCADA systems were completely disabled. Okay, through this attack. So I go through that in detail. So we could do a separate talk on cybersecurity. I just a lot of the diagrams I used in this talk are higher level diagrams, more functional diagrams, as opposed to trying to show detailed cybersecurity equipment. All right.
Thank you, sir. So, okay, the next question.
Sayed, I think you skipped the question for Sayed. So for Said, I think he was asking about the ones.
Oh, yeah. Okay, I'm sorry for that. I have missed it. Can we apply WAMS on distribution system? If yes, why do we have heard about just transmission systems that will host PMUS? Is that because of the economic shortages to afford the PMUS and then implementing the WAMS?
It's because of the business case. Okay. Think of transmission substations are much bigger and have many, many more points, right? And there's a lot less of them. For instance, in the United States, there's 15,000 transmission substations, but 52,000 distribution substations. So with distribution substations, they're smaller, but there's a lot more of them, okay? So if you want to apply technology that's new and you want to have the biggest return on investment, you would choose something that's very critical. Transmission is much more critical than distribution, and something that is bigger so you have more impact, like a transmission substation, than a smaller distribution substation. The same is true with asset optimization. We chose asset optimization to first look at transformers, right? Transformers are a multi-million-dollar asset. So it's critical, and there's more at stake. The business case is stronger. So that's why phaser measurement units, synchrophasers, wide area WAMs, wide area measurement systems, you know, it made sense to first apply those on transmission. That's where the biggest benefits would be. That's where the most criticality is. And that's where you learn. You learn from your transmission experience. And then what we've done is we've taken what we've learned from transmission and we've moved down to the critical parts of the distribution system. Not the whole distribution system, but the most critical parts of the distribution system, because that's, again, that's where the stronger business case is and where the economics are more attractive. So we started with transmission for obvious reasons. And then we are moving into distribution. And, you know, it all depends on the business case. Any business, any organization out there is just not going to apply technology broadly. You know, there has to be a business case. There has to be a reason. There has to be a return on investment that's attractive. And that's why, you know, I always say that if it's one thing to go through engineering school, but I think to be a valuable engineering industry, you need to have some business knowledge of the technology. That's why after getting a bachelor's and master's degree in electrical engineering and power, I wanted to get an MBA in finance, okay? Because I needed to understand the business side of the technology. You know, when you start working, the executives at your company, they're not going to be interested in bits and bytes and you know, detailed engineering stuff. They're going to want to know the business side of the technology. And for you to get a project approved, you're going to need to be able to put the business case together of a technical project. So I actually have a set of slides in the 3-day smart grid course that I teach. I spent about an hour, hour and a half on how to put the business case together for a technical project. Okay. It's so important to do that. So that's why you have to understand, you just can't apply technology broadly. You have to look at the business side of what you're doing, and it has to make sense, right, for the organization. Okay.
Thank you so much, John. Well, I'm handing over my rest of the part to Maisha Tafanum, Chair IEEE NSU Student Branch. Due to some reason, I will sign off today. And John, it's been an amazing session with you, and it's a treat to have you with us. Thank you so much, sir.
Okay, Saeed. Thank you. Thank you.
Thank you so much, Redwan, for moderating the session. And yeah, I guess I will thank you later on. you may go to your emergency work. So okay, bye. So I think we are done with the questions, right? I think we are done with the questions.
There's a few more, Maisha. Yeah.
I could ask, it says one of the questions, it says, smart meters have limited resources such as RAM, CPU, and extra. Otherwise, what we have more data types and data securing algorithms to provide a secure communication. Is that a challenge for smart metering?
It is a challenge because, you know, when we at GE had a smart meter business, let's say, think about, we're talking with Florida Power and Light and about a buying smart meters. Well, they're buying 4.5 million smart meters for a contract that's about $250 million. So if you add a little bit more memory or a little bit more processing speed in 1 meter, and it's maybe 5 cents more, you multiply that by 4.5 million, right? That's an increase in the contract, right? The value. So with it is a challenge, because with smart meters, the cost versus functionality trade-off is extremely important. You want to have as much reasonable functionality as you can, but you really have to be careful with cost on a smart meter. Okay. Now the one advantage with technology is technology, as new technology increases in the future, what we end up with is more functionality, and many times at lower cost, right? Because the new technology is less expensive. And that's what we're always looking at with smart meters, is more functionality, but without increasing the cost, taking advantage of new advances. Okay. Somebody asked about, it's funny, when I was president of PES, we were the 3rd largest society, 2006 and 7. And I'm very competitive, as you guys know. I want to win everything that I do, races and stuff. So I always wanted PES to be the best, right? The biggest. Well, and when I was president, Communication Society was 2nd largest, and Computer Society was always the largest. So we've since I was president, we're bigger now than Communications, so we're 2nd, and the largest society is Computer Society, and they have about 10,000 more members than we do. So if we continue to grow, which we are, and if I'd like to see us be bigger than Computer Society and eventually be the largest society. Now, let me add one other thing. There's 39 societies in IEEE. Okay. I said I've been involved with writing standards for 35 years, and that's just the substations committee. There's 17 technical committees in PES and 4 coordinating committees that write standards. PES, we're one of 39 societies. We write almost 50% of all IEEE standards. Okay, think about it. We write almost 50% of all the IEEE standards in PES, and that's one of 39 societies. That's very, very important. We're very strong in our technical committees and stuff, and that's why I wanted to get involved in one of the technical committees and eventually be chair of the committee. It's what a learning experience that is. It's just a valuable experience. So anyway, it's Computer Society is the largest, and about 10,000 more members than we have right now.
John,
Okay,
I do. Can I provide one additional information?
Yeah.
Yes, one additional information that makes us so proud is if you consider the number of students, members that you have in the PES nowadays, 25% are student or graduate student members. And if you consider all society students across the globe, for all the society that you have in IEEE, 26% of all students that you have with society membership, they are PS members. 26%. Yes, 26%. 26%. We have 40,000 society students and 11,000 PS students in nowadays. So 26%. This is amazing. We are growth very fast. And also my dream is to PS become the largest society. And this will be only the time, because I'm sure that if you keep this very growth that you have now, you'll become the largest as soon as possible. We'll have the amazing leaders, amazing young and students and channel leaders that you are driving us to this direction.
Right. Good info. I didn't know that, Tiago. So there's 39 societies. We're one of 39, but we have over a fourth of all the student members, our student members, all a fourth of the IEEE student members are student members of PES.
Yes,
Actually, John, if I could share, I mean, you see, I'm quite involved with, I mean, since I'm the student representative, so in my country, so I try to get involved with a lot of societies. I must tell you that I feel, I mean, honestly, with all respect to all societies, I feel only BAS is the only society where you feel you're a family. You know, from the upper management, you could reach out to anyone. There's the CTAC team, the YP team. It's just, it feels like a family. Even people like, okay, Maisha, she's coming from a CE, computer science background. And then it's like, you feel like the love for BS is more than, I mean, for example, any other society. So it really, it's not always there. You know, like BS, it just feels like a family.
Yeah.
yes.
I have my, see my
Nice.
global
Congress.
Student Congress shirt. Yeah, I mean, what's cool is I'm with the Global Student Congress, and you have all kinds of people all across PS. You know, I've been involved 50 years, past president, but I'm active with the Global Student Congress. So you're right. I mean, it's a family that doesn't have executives, or doesn't have, everyone's involved at the same level, and everyone's sharing information and helping each other. That's right.
Yes, and one additional point, Hussein, that you talked and John McDonald talked before. I believe it after PS changed the name to the Power and Energy Society, this attracted more people to the society too. I'm part of this example. My background, my undergraduate background was not in electrical power system. I am an aerospace engineer. And after that, I had a management engineer degree. So, but I follow energy fields as my passion in my master and my PhD degree in all my research. So this is an example, as you told about Maisha, that is from computer side, energy sector, attract people from different and talent from different areas. We need more people. You need more leaders like you have here in this session from different fields, independent of the degree that you have. Energy and power need this talent to improve the society.
Well, you know, you think about what I was talking about was the big data and data science coming from computers, computer society, and IT. We have need for that expertise in PES. Think about, I talked about power electronics. You know, we have a need for the PELS, Power Electronics Society experts, to work more closely with us in PES. So, I mean, you know, there's reasons why, that's why I did that in my talk. I mean, there's reasons why computer society folks should be with us. There's a reason why PELS members should be with us, because, you know, we have a need to work together. There's solutions. The solutions aren't siloed anymore. They're too interdisciplinary. We need to break these silos down and work together. You know.
John, I think we just have another two last questions they asked earlier. I think we just need to address them. Okay, one is, could you give some examples of what type of information could be taken from smart meters or be used for analytic purpose like big data? Thank you.
Yeah, a couple examples real quick would be the voltage from a smart meter that we bring into the network model in the distribution management system. And we use that in volt-var optimization, right? Because when we flatten the voltage profile and lower it, we don't want to implement that until we check what the voltage is going to be at the end of the feeder. And that's what we would use. We would ping certain smart meters to get that information. Another example would be the last gasp communication, the outage information. The meter now has an outage, and it communicates upstream to the utility that we have an outage. This is the time it occurred. We put that information in the outage management system. The OMS has the network model. It knows what customers are electrically connected to that feeder. So by getting that information from the smart meters, it knows exactly how many customers have an outage and the time it occurred. Okay, automatically. So that's two examples right there. And third example would be power quality information. Meters give us voltage sag, voltage swell, a lot of power quality information that we use also. So that's three quick good examples of smart meter data being used.
Thank you, John. And another last one is not a question, but it's more like he's asking about your opinion. He said, or she is from somebody named Last. Energy storage technology will accelerate the decentralization of the power grid to become a reality. And decentralization is an effective means to solve the destruction of large-scale power grids. What do you think?
Well, that's what the trend is. The trend is and that's why there's such an emphasis on microgrids today. Instead of having one large scale power grid, where if there's a problem and it cascades, the whole grid could go down, right? For more resiliency and more flexibility, let's look at strategic microgrids. So a microgrid could be islanded, and if it had enough generation, could operate on its own. Now, energy storage is critical because as we implement more renewable energy, remember what I said, there's intermittency, right? The sun doesn't shine all the time, the wind isn't blowing all the time, but yet the load has to be satisfied. So energy storage and fast starting, fast responding natural gas fired turbine generators, those are all fundamental to addressing the intermittency of the renewables. The increase, we're increasing the integration of renewables, but we have to deal with the intermittency in a real way. So there's no question, large scale central generation is a thing of the past. We're not building huge coal-fired power plants or oil-fired power plants. It's distributed generation, distributed all throughout the grid. That's reality. So the question is, how do we deal with the intermittency though? Because we have to deal with that in a very realistic way. Okay.
Okay. I think John, we have taken so much of your time.
Does anyone have any if they want to unmute and have any questions about?
I think there's a last question that somebody just asked now.
Oh.
Sorry, if possible to have an idea. Okay. What could be the impact on energy transition by using H2 on the existing subgrid?
There's a lot of research going on in using hydrogen on the grid, hydrogen fuel cells and things like that. Hydrogen powered transportation. A lot of it is still in research. A lot of it is in pilot proof of concept. The thing that there's so many aspects to this in terms of the business case and in terms of safety, so what we have to realize, especially students and young professionals, something may look good from a technology point of view, but it may not be attractive from a business point of view, or it may not be attractive from a safety point of view. In other words, handling of fuel may present a real problem. So we really have to, with hydrogen, we have to look at the complete picture of the application, the business side, the technology side, and environmental side, all the aspects of it. And it all has to make sense. It all has to be attractive. And to companies like GE, there has to be an attractive business case for a company to invest in it. Okay. Let me type my email here.
I think at this point, if anyone would like to just speak directly, just go ahead. We'll be maybe finishing in another 5 minutes.
Yeah.
Just
If
open your
anyone
mic and
wants
speak.
Yeah, you can just directly interact with the speaker. But by then, I had one question. Not actually question. I wanted to ask that what is the one or two advice you would give someone who wants to be a leader, or who is already a leader, wants to improve their leadership from your experiences? So what are the two advices that you think they should follow, all leaders should follow?
First thing is, what I always did was really observe in detail leaders that I respected, leaders that I felt were doing a good job. First of all, I really observed how they interacted with people, how they led, how they got things done in a team approach. Okay. Then secondly is I observed leaders that were not very good. Okay. And I have many of those in my years at IEEE. One thing in a volunteer organization is you don't choose your leaders too much. You take what you get. If somebody volunteers, you take what you get. Could be good, could be not so good. But you also, secondly, would observe people who are having trouble leading, having trouble getting things done, alienating people. They can't put a team together. Nobody wants to serve on their team because it's not enjoyable, or for other reasons. What are they doing wrong? Okay, that's second thing. Third thing would be find people that are good mentors, good leaders, and hopefully choose at least one of them as a mentor. That way you can get much closer to that person and learn in much more detail their approach to being a leader. Okay. When you can get close to someone in a mentoring situation, you can learn much more behind the scenes, much more insight into how that person approaches leadership challenges, right? Similar to the time we spent, Maisha, I think we spent 2.5 hours talking about how to build and lead a voluntary organization. And I gave you examples and I gave you guys techniques that I've used over the years. And we had a lot of discussion about that. That's what I mean. That's really gave you guys a lot of good insight from somebody like me who's been doing it for 50 years, And then the last part is the most important, is you have to, if there's something in my life, if there's been something that I didn't feel I was good at, I volunteered to do it. I put myself in a situation where I had to do it. When I got my master's and got out of graduate school, I knew I wasn't a really good public speaker. Okay. And I paid my own money to take a public speaking course at night. And I was so nervous and scared. I was sweating. My clothing was wet from sweat. I was so uncomfortable doing it, but I forced myself to do it because I had to improve. I had to do it. So the last part would be, put yourself in situations that you may not feel comfortable in initially, but then really work hard at doing well. You have to experience something to get better. You can't just be on the sideline and observe. That's not going to work. You have to jump in with both feet. It's like a swimming pool. You can put your toe in the water and think, oh, it's too cold, but you can't, you got to jump in and start swimming. You can't just be on it. So those are the things that that's what I recommend, those things. Okay.
Thank you so much, sir. Thank you so much. So anybody has any more questions? From the text of Hisham, I just remember to recognize the efforts of Hisham and of course Ahad Raj, the two volunteers who have helped us with the poster designs and all. Ahad and Hisham, do you want to say hi to our speaker?
Assalamu alaikum. It's my pleasure to do it.
Thank you.
Thank you.
Hisham?
Not get it. Was it Ahad? Okay, okay.
Yeah.
Hisham, do you want to go forward?
This is Hisham. Thank you very much. Actually, I'm not very much in power and battery and this field, but I still found this talk very useful, and I really enjoyed attending 2 hours of your session. Thank you very much.
You're welcome.
2 hours and a half, Hisham.
Yeah. 2 hours.
Time flies, you see. You know, when the session is interesting, just time flies. Thank you, Hisham.
Yes.
I think that's all. I think we have had enough questions, and I don't believe there's any more. Anyone want to participate anymore, or we could just end the session here? I mean, we are happy, but we are afraid that obviously John is very busy. Yet he was willing to give us 2 hours, 2 hours and a half of his time. Obviously, always John, I know he always says it's fine, I have time, but I mean, we all understand as somebody at your position, you know, like we understand you have been very kind with us, offering us all this time. Thank you very much. We truly appreciate it.
Yeah, well, I really enjoy all the time I spend with you guys. So feel free, and I really mean this, feel free to reach out anytime to get back together again. Okay.
Thank you, John.
Thank you, sir. Thank you so much. So Sulaiman, I just saw you just opened your camera. Do you want to say something? I think with that we will end it. You are muted. We cannot hear you.
I think he has a mic issue because even the mic is not appearing.
Did you connect to the PC? Okay.
Yeah, just type anything you could say in the chat.
So anyways, thank you so much to also Multimedia University Student Branch and the PS chapter. Thank you, Hussein, for collaborating with us. Hi, Bruno.
Yeah,
He keeps
so
on
Bruno will
pushing.
say goodbye.
Hi, Bruno.
His tail's wagging. See his tail?
Yeah, yeah.
He heard his name, so he's very happy.
Thank you for joining.
All right.
Okay, thank you everyone.
All right.
John,
Thank you, everyone.
John and Tiago, I think it's early there. So have a very good day. And to those in in Asia, I would say good night. It's almost 12:30 a.m. So thank you everyone for joining us.
Yeah, to the Malaysian participants, it's very late for you already. Like it's past 12. So thank you so much for staying.
To me, it's fine. I'm a night owl, I sleep like 2 a.m. Thank you, everyone.
We will catch up with you later on. So thank you so much once again, John McDonald sir, and we will be in touch soon. So Tiago, thanks a lot for being here like such a long time, and thank you to all the participants. Still, we have 23 participants here. We had more than 80. So yeah, thanks a lot. So we are officially closing the session now.
All right.
Bye. See you.
Bye-bye.
Bye-bye.
Bye. Thank you.
Hussein, did you stop the recording?
Stopping now.